What we have here is currently there's 8,000 bacteria present in the culture. When an antibiotic is added to the culture, the number of bacteria is reduced by half every hour. If the decay process repeated by the function is represented by the function f of x equals 8,000 to power multiplied by half the power of x, where x is the number of hours that have passed. Complete the graph. So look, you put it into your calculator. We all know how to do that. So what numbers did we get? 4,000, 2,000, 500 and 250, okay? Now, I have to go as far as 8,000, okay? So, I have to go from 8,000, from 0 to 8,000, okay? So, you can see your graph here. Now, let's count how many blocks I have. I'm going to count down in 4s, okay? I'll see what I can do with this. 4, 8, 12, 16, 20, 24. Now, 24 won't exactly go into 8,000 too easily. So, what I'm going to use, lads, I'm going to use 20 blocks, okay? Going to use 20 blocks, and on each of the 20 blocks, Sean, 20 blocks has to go from 0 to 8,000. So each block is going to represent what, guys? So if 20 blocks represents 0 to 8,000, what does each block represent? Divided by 20, so each block will be worth 400. So 2 blocks will be worth 800. So 800, 1,600, 2,400, 3,200, 4,000, 4,800, 5,600, 6,400, 7,200, and finally 8,000. Now guys, if I make it really narrow, what's the problem? If I make it really narrow, if I say it like this, 1, 2, 3, what happens then? It's very steep, okay? Hard to draw, exactly. If it's a curve, it'll look pointy. So let's drag it out. I'm going to do 4 blocks are worth 1. Just to really drag it out and make it easier to draw. I think we only had all the way to 5, was it? Yeah. So let's draw this now. 0, 8,000 here. 1 is worth what? 4,000. 2 is worth 2,000 is halfway between 1,600 and 2,400. 3 is worth 1,000. 1,200 is halfway between 800 and 600. So halfway between 1,200 and 800 will be 1,000. Okay, next one after that. 500, just above 400. And then 250, right? So just above halfway of the first one. So you're going to draw here your curve. Oh, sorry, messed up that last part there. Oh dear. There you go. So like that. Sean, Dennis, how do you answer the questions here? How many bacteria remain after 8 hours? So I drew the graph. Okay, and how many bacteria remained after 8 hours? Well, we don't know that from the diagram, do we? Why do we not know it from the diagram? Because it doesn't go all the way to 8 hours. So we have to continue halving it. So the 6th one will be worth what, guys? 6 will be worth 125. 7 will be worth, what's half of 125? And what's half of 62.5? 31.25. So there'll be roughly 31 bacteria left. After how many hours will there be fewer than 130 bacteria? How do you find out where 130 is? Alright, half of 800 is 400, okay? So you're gonna have to zoom in on this, and you're gonna have to like take a guess where 130 is gonna be. It's gonna be less than halfway, isn't it? So it's gonna be just roughly here. And this is a really bad idea. Yeah, do you know what? I think I'm with Sam on this. Do you see the 125? 125 is very close to 130. So you can just say roughly, just answer 6 hours. T equals 6 hours. You can say roughly 6 hours or just underneath it. Yes?
For the last one, I got 31.25 as well.
Yeah, I got it as well. That's it there.
Yeah, I got that as well. But I did it a different way. I put it in a
The next one is each year a tennis club has a tournament. Players start with 128 participants. During each round, half the players are eliminated. This can be represented by the function 128 to the power of a half x, where x is the number of rounds that would have been played. Draw a graph of the decay function for the first 4 rounds, basically from 0 to 4. How many players remain in the tournament after 5 rounds, and after how many rounds will there be a winner? So what I can do here, guys, is I can go to the calculator and I can go to the table function. I can go 128 then to the power of a half x. Okay. And then what we have here is starts at what, guys? 0. No, nobody's been eliminated. Let's just do it to 8 or something like that. Just do more points than we have to. Now look what happens. After round 1, there's 64 players. After round 2, after round 3, round 4, round 5, 4, round 6, 2, and round 7, we have a winner. It takes 7 rounds to win. So we can already answer this already. After how many will there be a winner? 7 rounds. How many players remain in the tournament after 5 rounds? What did we say it was again? After 5 rounds? 4. Shh. And does anybody want me to draw that graph?
No, but how did you do that again?
I went to the calculator. I put the function into my calculator. And I went 0 to 8. And what I said is, after no rounds have been completed, all 128 players are still there. After 1 round, 64 players are left. After 2 rounds, 32 players are left. After 3 rounds, 16 players are left. After 4 rounds, 8 players are left. After 5 rounds, 4 players are left. After 6 rounds, 2 players are left. And finally, after the 7th round, 1 player remains. He's the champion. Okay.